This presentation provides students details of the Unit 1B day discussion on polynomials, how to find all real roots of a polynomial using the rational roots test, finding an upper and lower bound for the zeros, and solving the polynomial. So here's our polynomial, and let's start this process to see how to find all the real roots. The first step in finding all the possible roots, or where the polynomial crosses the x-axis, is using the rational roots test. And this helps us narrow down our choices for what roots we're looking for, so we just don't start dividing any number. So to do that, we're going to find our p and our q. Now our p is our constant that's added to the end of the polynomial, and our a is going to be the coefficient in front of the highest term. And in this case, it's a 3. So I'm going to take my p and I'm going to divide it by q, and I get a 12 divided by 3. It doesn't matter if the 12 or 3 is negative or positive, and that's because I'm going to find both the positive and negative. I'm going to take the 12 and the 3, and I'm going to find all possible factors for the 12 and for the 3. And so on the top I get 1, 2, 3, 4, 6, and 12, and on the bottom the factors of a 3 are 1 and 3. Now I'm going to take each top number and divide it by both the bottom numbers. So 1 divided by 1 and a 1 divided by 3, and then a 2 divided by 1 and a 2 divided by 3. And if I do that, I'm going to get this list of all possible combinations, which is quite a long list. So what I want to try to do is narrow it down, because what this is telling me is that my roots for this equation can be anywhere from a negative 12 all the way to a positive 12. Bound test first and see if we can find an upper bound that's a little bit, encloses that gap a little bit more. So we're going to start doing synthetic division, and I just picked a 4 because I was hoping that it was kind of closer to 4. And when I find my upper bound, what should happen? I'm going to bring down my 3. This is synthetic division. I'm going to take the 3 and going to multiply it by 4 to get a 12. And at this point I'm going to stop, because a negative 13 and a 12 is a negative 1. And I know on the bottom that to be an upper bound, all of the things on the bottom, all of those solutions that I found on the bottom have to be positive. And once I encounter a negative, I can stop on the upper bound side. So I'm going to eliminate the 4, and now I'm going to try a 6. So I'm going to bring down the 3. I'm going to take the 3, multiply it by 6, and get an 18. That 18 I'm going to write underneath the negative 13. I'm going to add the negative 13 and 18 together to get a 5. And then I'm going to take the 5 and multiply it by 6, and I get a 30. At this point, I see that I get a negative 2. So I know now that this is not an upper bound. But if I continued on, I might see that I have found a 0, which might make me very happy. And at this point, because it's a third-degree polynomial, I could probably stop here and just factor that quadratic. But since we're actually trying to find the upper bound and show you how to do that, I'm going to go ahead and go to my next larger number, which is a 12. And when I put a 12 in, I see, if I do all my synthetic division, and by this time I'm figuring you've got the synthetic division down, I see that everything on the bottom is positive. So I know this is upper bound. Why again? Because the bottom row has all positive numbers. So I know this is my upper bound. Well, that didn't really help me very much, because that is as far as I could go on the right side. So let's find a lower bound. I'm going to try a negative 4. I'm going to do synthetic division. Again, I'm not going to go through that process because I figure you got it. And I see that I have a positive and a negative, and I'm saying, this could be one of my lower bounds. And so this is a possible lower bounds, because on lower bounds, I don't look to see if everything's positive. I look to see if it alternates positive, negative, positive, negative. But I'm going to try one more time. I'm going to go to a negative 3. And when I put in a negative 3, I also see this. Now, I've done this problem ahead of time, so I know that this is actually our lower bound. So I'm going to stop here just to keep this presentation from being really, really long. So all entries here are positive, negative, positive, negative. So now I know that even though my 12 is my upper bound, I have narrowed down my choices quite a bit, because now I know when that polynomial crosses the x-axis, it's only going to cross that x-axis between a negative 3 and a 12. So I know my zeros are somewhere in between this part. Now I'm going to solve for the zeros, and if I remember my upper bound, I remember that when I took that 6 and I started dividing, I kind of got to this point and I sort of saw that this would probably be a 0. So I'm going to come back to this point and I'm going to take what I started at the trying to find the upper bound, and I'm going to go ahead and do this, and I find out that my 6 is indeed a factor of this polynomial because my remainder at the very end is a 0, and I'm like, yay, okay, I found one of my zeros. So at this point, okay, now we're going to solve for the real zeros. When I do this, I see that my 6 is indeed a factor, so I'm going to write it out as a factor. And then my 3 and my 5 and negative 2 on the bottom are really the coefficients now in front of my quadratic. Why a quadratic? I went from an x cubed originally, 3x cubed. I took one of my x's out, the x minus 6, so now I'm left with an x squared if I take one x out. So 3x squared plus 5x minus 2. And now I need to factor this quadratic. So I have to find two numbers that multiply to a times c, and a is a 3 and c is a negative 2, so that gives me a negative 6, and adds to my b value, which is 5. And I'm going to find a 6 and a negative 1. Make sure that you don't see that it's a 3 and a 2. Those two won't work. They would add to a 5, but they would never be able to multiply to a negative 6. So I need a 6 and a negative 1 here. But be careful. These are fake factors. Okay, they are not real. Do you remember why? The reason is because my a is not equal to 1. In this quadratic, my a is a 3. So we have to do an extra step to figure out what is going on here. Okay, to solve for the polynomial for this part that's left, this part right here, what we're going to do is we're going to use these numbers that we found of what numbers multiplied to a times c and added to b, and we're going to use these. If we use the kick-it method, we're going to use these as what we call our fake factors. So I'm going to take these, I'm going to actually write them as factors, but we know they aren't the real factors because my a is not equal to 1, and I'm going to write these out like that. And then what I'm going to do is I'm going to take this a part up here, this 3, and I'm going to divide my fake factors by a 3. And you notice when I'm dividing these fake factors, I'm dividing the numerical part. So this 6 is divided by a 3, and this negative 1 is divided by a 3. Now, if my factors divide evenly, for in this instance, in this case, 6 divided by 3 gives me a 2, I'm going to go ahead and divide, and I'm going to get an x plus 2. And then on this side, I see that I have a x and a negative 1 and a 3. Well, I know that a negative 1 cannot divide evenly by 3 because I get 0.33333 because it's a third. So instead of dividing, I'm going to take this 3 and I'm going to do what we call kick it. And I'm going to kick it in between the parenthesis and the x. I'm going to kick it to the front, and I'm going to write that out as 3x minus 1. And I would have then my two factors, and I would see that x is equal to a negative 2 is one of my zeros, and x is equal to a 1/3 is another one of my zeros. And that's one method of doing it called kick it. A lot of my students like it because it's pretty easy. The other method is a method, of course, I learned in school, and I believe Miss Ferguson taught it last year. It's actually a very good method to learn because you use it in later stages of math. So that's one of the reasons we teach it to you at an early stage. All right, in this example, what I'm going to do is I'm going to use this 6 and negative 1 again. And so we're going to use those pieces again. And what I'm going to do is I'm going to take this 5 and I'm going to rewrite it into two things that add to a 5x. So I'm going to turn this 5x into a 6x minus an x. And if I do that, I can see that minus 1 is here with the negative x, and the 6 goes in front of here. And what I used to call this is the split b, like a split pea soup, but instead of split b, I call it split b. And we're splitting our b. So now I'm going to take this whole thing, and I'm going to rewrite it with my b split. And I'm going to have 3x squared plus 6x, this is where I'm doing my splitting my b, minus x minus 2. And there you have it with our split b right here. Okay, now what I'm going to do is I am going to take this and I'm going to split it in half again. And what I want to do is I want to factor out anything in common on this side. And I see that both of these have a 3 and an x in common. So I'm going to factor out a 3x. And if I factor out a 3x from a 3x squared, I'm just left with an x, and I'm going to put that in parentheses. And if I factor out a 3x from the 6x, all I'm going to be left with is a 2, so this x plus 2. All right, now it's real important to check to see if you did this correctly, and what I do is I check. If I went ahead and distributed this 3 back in here, I would get back a 3x squared, check, and if I distributed this as 3x into the 2, I would get back a 6x, and I look at this and I go, check, that's correct, so I know that I factored that out correctly. All right, now if I have this on this side, I actually have to have this x plus 2 on this side. So I'm going to go ahead and write this out. And then, because I know if I have this on this side, whatever's in parentheses, I have to also have in parentheses on this side. And what I find out is to get an x plus 2 then on this side, what I would have had to factor out is a negative. Now let's do our check again. If I multiply this negative times the x, I get back a negative x, check. And if I multiply this negative x to the 2, I get back a negative 2, check. So I know that's right. All right, now this negative really is a negative 1, so I'm going to put a 1 right there just so it doesn't confuse us. All right, now what I say is I'm going to take both of these things that are in parentheses, and I'm going to write this out as x plus 2. And then I always tell my students, now I'm going to write the leftovers. This is what I'm going to have for lunch tomorrow, my leftovers. And I'm going to take what's left over after I take out the x plus 2 everywhere, and I see that I have a 3x and a minus 1, and that is the group it method, and you can see it gives us the same factors as our kick it method. So either method that you want to use is fine with me. And now we have the solution for our polynomial written in standard form and linear factored form. The real zeros are x equals 0, x equal a third, and x equal negative 2. We can see that from the Desmos graphs below. And we then used all of the things that we learned in our day 1 class of polynomials to find all of our real roots, the rational roots test, the upper and lower bound, and finally just regular old factoring from our Algebra 2 days.